Today we are moving on, and we're moving on to dealing with systems of equations, which is similar to we're dealing with parallel and perpendicular lines because you did have two equations, which would be a system of equations, but now we're going to be working on being able to identify the types today, and later this week we'll get into solving them. Now the first question that comes up is, what is a system of equations? Well, a system of equation is going to be simply two equations that you solve together. There's going to be an x and a y in it, and you need to solve for x and you need to solve for y. Now when we talk about types of equations, there are two main types of equations. The first type is consistent, and that means that the system does have a solution. That would be the case of our perpendicular lines because they cross. Now, if it is independent, that means there is exactly one solution, as was the case of our perpendicular lines because they crossed at exactly one point. If it is consistent and dependent, it's going to have an infinite number of solutions, which is going to mean that the lines lie right on top of each other. They are one line. And that is why it's infinite, because no matter where you go on one line, the answer will be true on the other line. Now on the opposite end, if a system is inconsistent, that means that there is no solution, which would be the case for parallel lines because they will never cross each other. So the first part we have to be able to deal with today is going to be identifying systems by looking at the graph. And so here we have a graph that has a red line and a blue line, and as you can see, one's vertical and one has a slope that isn't undefined. So when we look at these to identify the type, step one is going to be, are the lines parallel? If that is true, then there is no solution, they are inconsistent. As you can see, these lines are not parallel, so therefore it is consistent. So then step two is going to be to do the lines intersect. If they intersect, as is the case with ours, then that means that there is one solution, and we want you to get in the habit of circling that one solution. And that means that it's consistent and independent. So I'm going to write down here, consistent and independent. Now on the other hand, if it is the same line, then that means there are an infinite number of solutions, and so while it is still consistent, it is dependent. That is not the case for ours, but these are our three steps that we're going to follow today for looking at our next couple of examples. So let's take a look at the next example. And our next example is, you see here this line in purple. Well, are the lines parallel? Well, that can't be the case because I don't see two lines. So therefore I know that this is consistent. Now, do the lines intersect? Well, once again, I only see one line, so they aren't independent. But because we see a line that is one and the same, if we wanted to get picky, we could draw the rest of the second line underneath it. But that means that this is consistent and dependent. So then let's take a look at example C. And I'm looking here, I see that the two lines are parallel. They're never going to touch, they're never going to meet, which makes this very easy in that this is inconsistent. Alright, so we're going to then move on to the next piece of this in the next video.